Hello, everyone, and thank you for joining us today. I hope everyone is doing well amidst this COVID-19 situation. But so I really appreciate everyone taking the time to join us for today's webinar. Topic of which being a contact-free installation systems. I'm joined here by my colleague Ahmad, and just to let everyone know that we are practicing our social distancing. We have been working from home for the last few weeks, but we have come together in our office here today for the purposes of the webinar. But we are a good 6 feet apart from each other, Ahmad, I think. So that's good. But yeah, so let's get started here. We'll just do some quick introductions. So my name is Karl Metcalfe. I'm VP of Business Development here at Integrity Products. I've been with Integrity Products for almost 4 years now. Degree qualified in business procurement and supply management, and I've over 18 years experience in the construction sector and the oil and gas industry. Joining me here today is my colleague Ahmad. Ahmad, would you like to do a quick introduction?
Yeah, thanks. It's almost 1 year. Speaking in terms of my education, I have a master's degree in materials in corrosion engineering. And while talking about my experience, I have almost 10 years of experience dealing with corrosion, whether in terms of my capacity as a field inspector, asset integrity, as well as R&D professional.
Thanks for that, Ahmad. So just for today's agenda, we're going to have a quick overview of corrosion insulation and the stress corrosion cracking. We want to talk about our approach to product development. Of course, non-contact insulation systems, which is one of our newer products that we have developed. In relation to that, then we're going to be talking about the ASTM G189 testing, which we have completed, and some of the results which we have seen. We'll do a quick overview then of our product range. We'll move then to a quick summary of our presentation here today, and then we'll leave the floor open for any questions. So any questions that you may have, you can feel free to ask them towards the end. The chat button is located in the bottom bar to your left, so you can just go down there and click that button, and you can put your question in there, and again, hopefully we'll get to answer as many questions as we can. Any questions that we don't get to answer in the questions section towards the end, we will be hoping to contact those people directly afterwards to make sure that all their questions are addressed. So yeah, let's kind of get into our webinar here today. So as I say, one of our focuses here today is corrosion and insulation, but for me, Ahmad, huge amount of attention is paid to CUI, but it's actually just one of many different degradations.
Yeah, absolutely right. Yeah, although like CUI, corrosion under insulation, is listed as a standalone degradation among the 70 different degradation types by American Petroleum Institute, but it's interesting to know that like the CUI itself has the capacity to trigger other damage mechanisms, for example, or the vice versa. And it is quite interrelated to chloride stress corrosion cracking and sulfate stress corrosion cracking. So even looking at the definition, the latest definition being suggested by the API standard that says the external corrosion and external chloride stress corrosion cracking. So basically that is the both of these things, external corrosion and chloride stress corrosion cracking, are being addressed under the umbrella of CUI itself. So even chloride stress corrosion cracking is a separate degradation, but because of the failure mode of CUI, so that is being included under the CUI. So speaking about the CUI, it was reported as early back in 1950s, but the recommendations to address this issue came in the mid 80s and the late 90s. In the late 90s, we had NACE SP 198 document. It was issued back in 1998, but the most focus of this document was about the coatings, protective coatings for the CUI mitigation. And when we talk about the impact of CUI, so it's a widely accepted and published fact that 40 to 60% of the piping failure, overall failures, is because of CUI. And if we try to narrow it down and try to quantify that in terms of pipe size, so this impact is much higher for the small size piping. With the piping with the 4 inches and less, 81% of the failure is because of the CUI. And another case study that was published by ExxonMobil, I believe in Corrosion 2003 show in San Diego, California. So that has revealed that 10% of the maintenance budget of any hydrocarbon industry is spent in dealing with the CUI related damages. So here, as I just talked previously about the stress corrosion cracking, so it could be sulfate stress corrosion cracking or the chloride stress corrosion cracking. So again, the concept is same, both are external to the surface of the pipe. So as we can see in the snapshot on the left side, so there are the cracks, interconnected cracks, and they are originating from the points of highly corroded zones. So we can see in the snapshot. And if we try to analyze those cracks using the microscope, we can see that on the right side in the micrograph, it's a low magnification micrograph showing that these cracks are happening at the grain boundaries. So grain boundary is the location where the corrosion happens, and the same location the crack is happening. So it's a stress corrosion cracking mechanism, as I just mentioned that. So speaking about the CUI, so like it's a widely accepted fact that the CUI is a problem, is a prevalent degradation across the industry. But still there is a uncertainty. It's still a gray area when we try to quantify the impact or the probability or the consequence of CUI. So even the modern recommended practice for the semi-quantitative analysis of CUI that is most widely used, that takes into consideration the design factors for calculation of CUI. So those design factors could be even the material composition itself, the base corrosion rate of the material and also it takes into consideration the geometrical factors, the interface of piping and the pressure vessel or the storage tank itself, or it could take into the various complexity factors. And also it takes into consideration the insulation factors. That could be the type of insulation, whether we are using a calcium silicate, or we are using the mineral wool insulation, or it's a foam glass, this type of insulation, and the impact of the type, as well as the age or the condition of insulation, and also the surroundings that have a decisive impact towards CUI. So when we say speak about the surroundings, so it's an external environment, and also it's the neighborhood factors. So external environment could be the proximity to the marine location, or it could be the cooling tower drifts itself, or it could be the water spillage from the leaking lines, or from any neighborhood maintenance activity like sort of hydrojetting, hydroblasting activities. So these are all the factors that actually contribute to the CUI probability. And again, the consequence can vary depending on the severity of the component that is being subjected to CUI.
Yeah, so just to talk about then our approach towards our product development, I think it starts either by seeing firsthand problems that our clients are experiencing in the field, or a lot of time it's from just making ourselves familiar with some of the published research that's out there, and also kind of the standards that have been displayed across the industry. So from there we look to design and start to prototype product ideas. We have capabilities of doing our own in-house technical drawings, and we've got 3D printers. So from that we can kind of very easily visualize and get our first kind of product prototype in our hands. Usually from there then we're looking at doing our own in-house shop testing. But at the earliest stage, we're looking to actually push that out to kind of larger scale field trials. Then once we compile that information and we see how the product has done in a field installed condition for number of months or whatever it may be, we look to then like do final validation on the product, any sort of refinements we wish to make. And we then usually try to push towards, you know, doing some third-party independent testing. And then we approach our goal of having a finished, ready for market product. But what we're very in tune with as well is that we want to give back the lessons which we have learned, give it back to the industry. So we publish many papers. I think Ahmad over 20 papers at this stage, which is fantastic. But we're also kind of active participants in some of the API standards as well. So everything that we try to develop, we try to take those lessons learned and share them with the industry. Our mindset towards approaching the CUI problem has been that there's no one silver bullet which is going to solve the problem, but it absolutely starts like at the design stage. If the designers are considering CUI and other degradations right from the design stage, then they will build better systems. But we believe it very much so that it's kind of multiple barriers with you know, pipe coatings, good insulation selection, you know, auxiliary products as they're required, and then of course not to trap the moisture, to be able to detect and drain it. And then of course regular inspections are key for catching any potential problems at an early stage.
Yeah, so thanks, Karl, for that info. So speaking about the contact-free system, that is actually the theme of this presentation. So the contact-free system, while we look at the API standard in the NACE SP198, so they are actually in consensus about a certain thing that is called contact-free systems. So like if we look at API 583, that suggests that contact-free insulation systems prevent water accumulation and chlorides build up on the steel surface. So basically, that is suggesting that even if the insulation is soaked or it's saturated with the moisture, we should be having a provision that will allow to keep it away from the pipe itself. And even if we look at the NACE SP198 standard, that actually cracking a myth by declaring that CUI, the cause of CUI is not the insulation, rather it's aerated moisture, or I would say the water containing CO2, oxygen, and all those dissolved gases. So again, so by having a contact-free system that can keep the aerated moisture away from the pipe, so that would be an effective mitigation for towards CUI.
So leading from there, then we have developed a few different systems for creating a contact-free insulation system. We have our silicone blocks, which are installed via banding. They can just strap directly to the pipe, and then your insulation is just oversized and placed over them. We also have our PPS spacers, which simply stab into the insulation and make for a very easy install. And again, just stab directly into the insulation, and then it's placed over the pipe. So they work very well. And then, as I say, our latest product then being our PTFE spacer wrap, which is a full wrap which is installed directly onto the pipe before insulation is installed. Here we have just a few images just to show how that's done. So you can just see in the top left-hand side, our silicone blocks have a slot built through them, so you can just easily install them with a band. And then the insulation or whatever you need, like, can just go straight over top. The polyphenylene sulfate spacers, as I say, they have that spike on them, which just allows you to stab it directly into the insulation, and then the insulation is placed onto the pipe. Both of these, we've tried to minimize the actual contact points between the device and the pipe itself. And then our PTFE spacer wrap is a fully encompassing wrap, which is placed on the pipe prior to insulation being installed. So with our PTFE spacer wrap, you can see here that it's installed with the dimple side down. So you're creating a 6 millimeter gap between the pipe surface and the insulation. We recommend on the longitudinal joint that it's just going to be a butt joint. There's no need for an overlap at the 6 o'clock position. And for a circumventral joint, we recommend a 2-inch or 2 dimple overlap. And we are also recommending the use of non-metallic strapping or tape to install it. So our recommendation for this is the 3M69 tape, which is a high temperature tape. Again, here's just a nice visual kind of showing it very clearly. We've got the PTFE spacer wrap placed directly onto the pipe. We then have the insulation going over top of it and the finished then metal cladding on the outside. Just a couple of field photos from a recent project that we are working on. So in this scenario, the contractor involved did use a metal strapping, but as I say, it's not something that we recommend, just because of the potential to, you know, poke a hole in the PTFE spacer wrap itself. But you can see here that it's placed on the pipe, it's overlapped, the insulation is then placed over top of it. So we were very happy to get this product onto our first project and get some nice field shots of it being installed as well.
Yeah, thanks, Carl. So I would like to share some findings from our testing project that we recently completed in collaboration with National Research Council Canada. And the aim of this testing project was to check the CUI performance of different types of insulations and different configuration of insulation systems in conjunction with the spacers and the low point drains. And for the sake of this testing, all the testing was conducted as per ASTM G189 standard by a third competent party. And here is the experimental setup that is showing the arrangement. So for this testing, we used the carbon steel. Uncoated carbon steel was used as a test coupon. And in this end, that was covered with the insulation and the jacketing. And on the top side, we can see there is a funnel meant to introduce the electrolyte into the cell. On the right side, we can see an immersion heater. The aim is to increase the temperature of the cell up to 100 degrees Celsius. The reason why we are using 100 degrees Celsius is that it's the most favorable range for the CUI. So for the first phase, so this project was actually divided into two phases. As a part of the first phase, we checked mineral wool insulation as well as the hydrophobic blankets in terms of CUI performance. So that was the phase one, and also we tried to check the performance in the mineral wool insulation in the presence of the PTFE spacer wrap. So here are the three candidate systems shown in the figure. Mineral wool directly in contact with the pipe, hydrophobic blanket directly in contact with the pipe, and the contact-free mineral wool insulation with the help of PTFE spacer wrap. So speaking in terms of experimental results, these are the snapshots of the samples, corroded coupons. So on the left side, we can see the original sample that was before the corrosion test started. So this sample is containing grit 600 finish. And the next sample that was held directly in contact with the mineral wool. The third one was directly in contact with the hydrophobic blanket. And the last one that was wrapped with the mineral wool insulation, but the contact-free system was achieved using the PTFE spacer wrap. So here, something to observe is that, like in the last sample on the right side, so there is no corrosion at all on the surface. Rather, there is a change of the color because of the high temperature oxidation on the surface of the metal. So there was no pitting or the general corrosion in the presence of PTFE wrap. And not only we did examination of the corroded samples, but we also visualized the condition of the insulation after the testing was over. So the mineral wool insulation that was directly in contact with the pipe, so that clearly contains the stains of the corrosion from the surface of the coupons. And whereas the mineral wool insulation that was having the PTFE spacer wrap in between, that is not having any signs of corrosion at all. And also this insulation was almost dry when we removed it after the testing was over. So I would just take the opportunity to mention about the test conditions. So testing was conducted at a constant temperature of 100 degrees Celsius for a duration of 72 hours. So after 72 hours, this is the condition of the insulation. So Speaking in terms of hydrophobic insulation, that was also held directly in contact with the pipe, that was almost behaving in the same way. And we can clearly see the stains of the corrosion from the coupons on the 6 o'clock position of the insulation. And here is the summary of the corrosion rates that we calculated for the corroded samples by using the mass loss data. And so we can see from these histograms that mineral wool was having a slightly higher corrosion rate, almost very close to each other, but slightly higher corrosion rate than the hydrophobic, than the sample that was directly in contact with the hydrophobic blanket. And only the sample that was protected by the PTFE wrap never showed any signs of pitting, general corrosion, or any signs of stresses on the surface, stress screen cracking on the surface. So as a part of the phase 2 of this testing project, so we used 3 different configurations, and every configuration was made using the mineral wool insulation. So the first configuration was the mineral wool insulation directly in contact with the pipe. And the second configuration, we created the contact-free system using PPS spacer, as Karl mentioned earlier, polyphenylene sulfide spacers, to create a 16 millimeter gap between the inside of the insulation and the outer skin of the pipe. So that contact-free insulation we created, and on the 6 o'clock position, we installed the low point drains or the integrity drain plug. This is one of our products. So we installed that at 6 o'clock position. So that was the second arrangement. And the third arrangement that we made for the sake of the phase 2 of the testing, so that was mineral wool insulation directly in contact with the pipe. And on the 6 o'clock position, we drilled the drain hole. So here we can see in this figure, so this drain hole looks a bit weird in terms of the fact that it's a misaligned. So when we say the low point drain hole, so it's a combination of the hole in the jacketing and the hole in the insulation. When these holes are concentric, or means aligned to each other, then it's a perfect hole. But even like in the presence of pipe vibrations, thermal expansion, some mechanical loading, or someone sitting on the pipe, there is a likely chance that these holes can misalign from each other. Even the, if,
And the API standard call for a drain hole at the 6 o'clock position.
Exactly.
But simply a hole rather than any sort of device.
Absolutely, yeah. So, but it's not giving any clear recommendation of how to protect that hole. Even API says that like maintaining the rust-free drain hole is a maintenance nightmare. So there is no clear recommendation how to drill that hole or how to protect that hole from these damages. Yeah. So each of these configuration was tested against 2 conditions. So there were 6 tests being done in the phase 2 of the project. So one was isothermal wet and dry condition. Which means constant temperature. We created wet and dry condition for 72 hours. And there was another one with a cyclic, or I would say fluctuating temperature between 38 degrees Celsius to 100 degrees Celsius for a duration of 96 hours or 4 days continuous testing. So from this testing, we got the mass loss data, and we converted that into the corrosion rate using the applicable ASTM standards. And here is the summary of the corrosion rates for all these configurations. So we can see that the middle 2 histograms, the contact-free system that was achieved using the polyphenylene sulfide and the drain plug, that is having a much lower corrosion rate than the rest of the candidate systems. And the reason is that the contact-free system is delaying the degradation on the other side. The low point drain is quickly draining the electrolyte from the system.
It's interesting here, Ahmad, that there's actually virtually no difference between the closed contacting system and the system with a drain hole. Just once that drain hole becomes offset between the hole in the insulation and the hole in the cladding, or it gets it collapses or gets clogged somehow, it shows that there's very little difference. You might as well not have a drain hole at that point.
Exactly, that's the point. Either then we have to either re-drill the drain hole, or we have to find some mechanical device, some hardware likes of drain plugs that keep it like a robust and keep it operating for the.
And keep that cavity clear. Exactly. Excellent. So yeah, we just want to have a quick look then down through the rest of our product range. Some of these may be the subject of future webinars here, but yeah. So in our product range, we do also have our innovative inspection ports, which are called integrity plugs. These kind of have a flexible metal skeleton built into the edge trim, so they allow you to they're able to contort and fit to the curvature of the cladding itself, so they allow you to form a really nice watertight seal. Even if they were to maintain like mechanical damage or whatever, they still maintain that watertight seal, which is just so important when installing inspection ports. We also have a similar product called our fire plugs, so it's a fire-rated inspection port. We have our integrity pillows, which work in conjunction with our integrity plugs. And what these are doing is just replacing the cutout insulation piece. But we make them from a high temperature vermiculite fabric. So if you've got a very high process temperature, these kind of act as a heat shield for the inspection port itself. We also have our integrity water indicators. So these are, again, a simple device similar to our drain plugs, except they have a small hydrophobic elastomer ball built into the housing of the device. And when that comes in contact with flowing water, it just pushes out this orange notification. As mentioned earlier, we've got our silicone and polyphenylene sulfate insulation spacers. We also have our integrity termination gaskets, which form a watertight seal at any point where you're looking to terminate the insulation. We make these for every pipe size, every insulation thickness, and they've been a key part of our product lineup as well in recent years. As discussed in some of our testing there, we have our integrity drain plugs, which again are simple device made from polyphenylene sulfate, so incredibly durable and hard wearing, high temperature resistant material. And these can install up through the metal cladding and up through the insulation. They have a serrated cutter head on them, which allow you to core out the insulation piece for install. And then you can see those breakaway points all along the neck of the device, so you can just snap them off with your hand to suit your insulation thickness. We also have integrity clamp covers, and these were created in order to be able to form a watertight seal around penetrations from Grinnell clamps on the piping. Again, traditionally you would, the contractors would build a metal box or try to seal around the clamp with silicone. Usually a difficult enough piece of work, but we've created these integrity clamp covers. Again, we have them in various different sizes to suit many different applications. This is one of the latest products which we've been working on, and it's a whole kind of system approach kind of thing. So it's made up of a PVC dimple wrap which goes on the outside of the insulation, and it creates a gap between the insulation and the finished metal cladding. Work in conjunction with vents built into the sides at the 3 and 9 o'clock positions of the pipe, and also a drain tray at the 6 o'clock position. So what this product is doing is allowing any moisture which has built up in the insulation, it's giving it a gap between the cladding that it can flow into, and then water or moisture can freely leave the system. So this product is very new. We're still conducting field trials with a major asset owner here in Alberta, which has been fantastic. But there'll be certainly more to come on this over the next coming weeks. So just to summarize what we've gone through at the moment, then we had a look at CUI and the related degradations. We talked about contact-free insulation systems and our PTFE spacer wrap. We took a quick look at the ASTM G189 testing which we conducted and some of the results which we've seen from that. And then we also done just a quick overview of the rest of our product range. So we'd like to kind of just leave the floor open now for some questions. Ahmad has been keeping an eye on these. Ahmad, any particular question that you'd like to start with?
Yeah, so he mentioned that he's asking that I mentioned about 10% of the maintenance budget related to CUI. So his concern is whether this 10% budget spending is proactive or reactive. 10% budget is necessary to spend on actions related to avoiding CUI, or 10% of budget may be required to overcome, rectify the damages done by CUI. So like responding to this question, because since this case study was published in 2003 in NASCO, so I believe at that time, like most of the ND techniques, the latest ones, you know, like even those weren't available at that time. So I think this 10% could be most likely, even I'm not sure how they have the details of how they got this data, but I think it most likely there could be the reactive approaches that constituted it up to 10%. Definitely with the advanced measures and with the advanced ND techniques where we can detect the wet insulations, where we can take the alternative measures to prolong that, to minimize that degradation, definitely this number can be suppressed. I would say yes.
We have another question here saying that we found that some insulation fabricators void their warranty if drain plugs are used, and how is this managed? So again, that's not something that I've come across in the past, but I do know that the industry standards call for drain holes, so I'd imagine that any fabricator would have to build a product to suit the standards. But I mean, that's certainly a question that it's worth looking into, I think.
Yeah, I would comment on that, like one comment on that.
Sure, yeah.
So I was looking one of the research papers, so maybe the person who is asking this question, he can refer that paper. So there was a paper published in 2017, and the name of the journal is called Case Studies in Thermal Engineering. I can send the copy of that, so maybe you can drop us an email. So in this paper, it says that the hydrophobic insulations, once they go to the immersion condition, they keep on absorbing the moisture. So as they mentioned that the aerogel, this is one of the type of the brand for the hydrophobic insulations. So as this paper has revealed, this research paper, that under the immersion condition, these hydrophobic insulation can take the moisture. So I would imagine that at 6 o'clock position, so where we used to install the drain plug, if there is no drain plug, there would be immersion conditions. And again, the performance of hydrophobic blankets can be seriously compromised. So I would say the role of the drain plugs or the drain openings cannot be, you know, like undermined in any scenario. So you can just send me an email. I will share you the details of that paper.
And I think that's an interesting topic as well, Ahmad, that in using hydrophobic or moisture resistant materials, that they work both ways, that they, you know, when installed well, they can certainly you know, help prevent moisture ingress into the system. But if moisture is to get under a hydrophobic material, it's still hydrophobic from the inside out as well. So if moisture was to ingress through you know, any termination or penetration in the system, or even condensation buildup on the pipe surface, that hydrophobic materials can act as, you know, they're almost trapping the moisture against the pipe surface.
Exactly.
So that's an interesting place. We had another question here from Robert, just asking for some pictures of the testing that we done in the hydrophobic insulation with the PTFE spacer wrap. But yep, definitely, Robert, we'll be able to send you some of those those photos here afterwards. But thank you for that. Anything else, Matt? Another question that we got just beforehand was how does the PTFE spacer wrap install on bends or any sort of sweeps in an insulation system? So again, interesting question, and we've for the most part it installs very well. It's very malleable and easy to work with. It's kind of cut into peels, similar to the way that you would cut the metal jacketing in taking kind of a large sweep. We've also worked with some of our distribution partners who have fabrication facilities that they can you know, do this work off-site in their fab shops and have it sent out to site ready to be installed. But yeah, for the most part, what we've seen is that yeah, it doesn't really present too much of a problem. And I'll say it's kind of very similar to the way the metal cladding would be installed on a sweep or a bend as well.
Okay, so another question from Joe. He's asking that, can you explain why offsetting drain hole between insulation and jacketing caused more corrosion rate than direct contact mineral wool? Yeah, that's an interesting thing. So Joe, in this regard, I would say the offset drain holes means like a clogged drain hole. So means there is no drain hole in that scenario. So I would imagine the corrosion rate should be same in both of the scenario. But I think there is also some, like some level of, variation or the tolerance between the test results, because we are using the mass loss data. Yeah. And if you can see even the error bars in the histogram. So we may imagine a little variance to happen, but still we are investigating that, because there were two conditions. One was the isothermal wet and dry, the other was cyclic wet and dry. And you can even see that the corrosion behavior or the weight loss behavior is somewhat different in both cases. So we are still investigating into the reason why, like this behavior is like that. So yeah, you can drop us an email as well, and maybe we can able to share you the further details.
Discuss that in a little bit more detail.
Exactly. Yeah.
So it could be just down to just test variance kind of thing. But I think our test did show that the offset drain hole was slightly better than fully contacting, but very, very similar. Right?
Very similar, almost in proximity.
Another question we have here is just that what weight can the dimples in our PTFE spacer wrap, what can they handle? Like, are they going to collapse under the weight of the insulation and the metal cladding and stuff installed over the top? But they're actually incredibly strong. We have found that our PTFE spacer wrap can take about 4 pounds per square inch at room temperature, and up to 2 pounds per square inch when it's brought up to full temperature of 250 degrees Celsius. And again, once we've seen as well that during our testing that when the insulation is then also installed on top of it, and it helps kind of spread the weight of any, like if someone was to stand on the line or there's some sort of mechanical damage, that again, it's extremely resistant. So we have, one other question here is, does non-contacting insulation come in both cold and hot piping? So I think with that, we've only worked with hot piping at the moment, but it's certainly on our radar for a cold system as well. Our PTFE space wrap is a very new product, which we just launched late last year. So yeah, for the moment, our focus has been on hot insulation systems, but certainly a cold insulation system in the future might be something that we'll work with.
Okay, so another person has mentioned that. So they have the pipelines over the sleepers, and they get buried in the snow during the winter time. So if they are likely to have the drain opening in that sort of scenario, so there is a possibility that moisture can seep into the system. How to deal with that with this case? Now, that's a good question, I would say.
Yeah, and I think we've seen, like, with our drain plug and even our the vents that we use with our IVS system, that there is some potential for moisture to enter the system, but from what we've seen, it just, due to gravity, it's just going to come straight back out. But if it's in a fully kind of submerged position where it's surrounded with snow, I don't really know. I think it would be, I think you'd have bigger problems at that stage, Ahmad, like, if you're looking at the laps and the cladding and everything as well, like that, if it's fully kind of submerged in snow. Yeah. So again, I think that's something that we'd have to kind of think about a little bit more, perhaps, come up with a kind of full answer to that question.
Exactly. And also, like, we can, Karl, definitely share them the photos from the Western Canadian side. So they're like, even during the winter season, so the moisture was coming like the snowflakes from the inside of the pipe. So that was the similar scenario. But I think the labs could be also be the potential location for the moisture ingress, not only the drains.
Yeah, because I still think with the laps in the metal cladding, it's, some specifiers want to seal them, others don't. Yeah. There's pros and cons to both. So it really kind of depends on the individual system and orientation of the pipe.
Yeah. Another question is that about the testing as per C1617 standard. Yeah, this is our own future radar. We would be conducting that in the future. But like ASTM G189 is also like a widely accepted criteria for accelerated CUI, because for C1617, maybe few days we have to submerge the system. So, but G189 is like accelerated CUI testing. So we have done that, but definitely C16, 17 could be an interesting thing to do. Okay, so another question is asking surface with the question mark.
Yeah, so how is...
Yeah, there are two one. Okay.
So how does this non-contact free system work on plane surface? Yeah, I'm not really understanding that question, but again, we will, perhaps reach out to you directly and try to gain a better understanding of your question, and then we can certainly answer that for you.
Yeah. Another question is that with the surface. So I'm not sure what is the exact question. Oh, surface. Okay, okay, sorry about that.
Has a cost comparison been done between the RG 2400 PolyGuard and your PTFE system, both material cost and installation cost? So thanks for that question, Terry. No, this is not a comparison that we have done to date, but would certainly be something that we'd be interested in doing. So, and we are very familiar with PolyGuard. We've a lot of friends in PolyGuard. So I mean, that would be something that I'd be very happy to reach out to them with and discuss. Because very much so, I think what we aim to do is to bring our products to the industry, to installation manufacturers, to other colleagues in the industry, and as I think what we're all trying to do is to come together to build a system that gives us all the best chance to mitigate CUI problems.
Question: have you done any study on long-term testing on drying time with contacting temperature of 100 degrees Celsius with and without drain hole and plugs as the moisture is driven out in hot water vapors form? Yeah, so Joe, we are conducting a testing, like it's a field trial ongoing right now at one of the asset owner site. So we have this complete IBS system in place. We installed that back in October and November, so it was exposed to full Canadian winters for the 2019 and 2020. So we are checking the moisture data for the installation after every 14 days interval. So definitely we would be come up with some findings, and we would be able to publish that very soon.
Yeah, it's been fantastic doing those moisture tests, and we've gained a tremendous amount of data from it. I think initially we did start that testing, which is done on a large 3-kilometer test section.
Yeah.
We started it towards the end of October, and I think right away, Ahmad, like over a 4 to 6 week period, we were already seeing significant drop in moisture content of the insulation, and it was fantastic as well because, as you said, we're doing it right in the heart of the harsh Canadian winters.
Yeah.
So we were able to see a lot of physical evidence from moisture leaving the system. So that was great, but yeah, that testing is still ongoing. So we've been doing it for like almost 6 months now, and we'd be very eager to share all our findings from that testing as soon as we've completed it. But yeah, thank you for your question, Joe. So we have another question here asking if we can install the PTFE spacer wrap to surface also, and not only pipes. And yes, absolutely. It does come in a roll format. They're 75-foot rolls. It acts almost like a plastic, like it is a Teflon, so it's very malleable. You can install it on a flat surface, or it very easily, you can also install it onto piping, any size. You can just kind of cut to the circumference that you require. But yeah, you can install it in any orientation you wish.
Yes, asking how we take the moisture content of the insulation system. Joe, we are using the moisture meters for that. So
yeah. And Joe, what we did there as well is we've got on the trial section that we were doing, we had 18 different test locations, and then at each location we measured the moisture at the 12 o'clock, 9 o'clock, 6 o'clock and 5 o'clock positions, and then also at 3 different depths in the insulation. So we have a moisture reading from the pipe surface, the midpoint of the insulation thickness, and then of the outside edge of the insulation. And so it is a very detailed test that we're doing. We're seeing it over a large area, and I'll say also at kind of key points
on the installation as well. So yes, again, and so it's been fantastic to get all that data. What we're trying to do now is to kind of, you know, summarize it and put it together in a way that we can share with everybody. But again, thank you for your question, Joe. Great. Well, everyone, we really appreciate all the questions that came in, and we hope that we've been able to address them for you. Of course, we remain contactable if anyone needs to, you know, reach out to us directly. You can see both myself and Ahmad have our contact details here. Our info line for Integrity Products is info@integrityproducts.com. You can also be contacted through our website. And as I said here, we've got, we are very active on LinkedIn and Facebook. It's kind of where we bring our newest product and company information. You'll certainly see some future webinars listed there as well. And just one other item then before we finish is that for today, we did actually have a small prize draw going on for everyone who attended the seminar today. So we had picked out 2 winners. Each winner will be contacted directly here after the webinar and will receive a $100 gift card of their choosing. So our first winner, Ahmad, was participant number 30.
And he's Briaz.
Shazay Briaz?
Yeah, he's from Australia.
Very good, from Australia. Well, congratulations. Our next winner then was number 69, was Sterling Jacob. So again, for both those persons, we'll be contacting you here right after our webinar, and we can arrange that gift card for you and everything goes with you. But just like to say thank you very much for everyone who attended the session. We really appreciate your time, and we hope to bring you more of these webinars in the future. Rich asks us what currency is the prize money, but rubies? No, it's going to be 100 Canadian dollar gift cards, so probably not worth very much to a lot of people, but yeah, no, it'll be it's, as I say, it's just a little thank you from us for everyone who registered for today and was part of our webinar. So thank you very much, everyone. We look forward to hearing from you afterwards, and as I say, hopefully this is going to be the first of many webinars with Integrity Products. Okay, thank you. Thanks, everybody.